We solved systems equations with graphing, solving by graphing the other day. Easy stuff to do, easy to graph. Y equals mx plus b, plot them, be done, see where they intersect. That's all well and good, but sometimes you're not going to get nice and neat answers. I'll do one that's ugly in a little bit. We're going to start with some relatively easy ones, just to give you an idea of what we talk about when I say the solving with the substitution method. And we'll get into ugly. Now, the first one that we do, pretty simple. Y plus x is equal to 12, or x plus y is equal to 12, and y is equal to 2x. Now, with this problem, you're looking for one thing within them. You're trying to find an isolated variable, a variable that's all by itself on the side of the equal sign. Now, we did have those when we had the systems of equations where they were written in slope-intercept form, but those were nice and easy to graph, okay? I'll show you one in a little bit. Just hold your horses. But with this isn't written in slope-intercept form. Yes, you could turn it into, you could move the x and turn it into slope-intercept form, but you're going to start to realize that there are easier methods than graphing. They are telling us that y is equal to 2x. That means this y up here is actually 2x. I could substitute it in for it. Take this chunk, put it in for that y, and it would turn into x plus the 2x is equal to 12. Look at this horribly difficult 1.5 step equation. I know that 1x plus 2x makes 3x is equal to 12, and I divide by 3, and it tells me that x equals 4. I'm halfway home. X equals 4. I could go up to the original equation and choose either one. This is where it's your choice. I could change the x in either one of these problems into 4. Whatever's easiest for you. I'm going to choose this one because I know that 2 times 4 equals 8. So it's telling me y equals 2 times 4. Y equals 8. You could write the answer like this, but they actually want you to write it as an ordered pair because that's the solution. That point right there is the solution for this equation. So I take this point, and how do I know if I'm right? Because sometimes you'll do all this beautiful work and it's wrong. So how do I check? I take this point and put it into, not the one that I already used, into the other one and see if it makes a true statement. I change the x into a 4. I change the y into an 8. Is 4 plus 8 equal to 12? Winner, winner, chicken dinner. That point does work. Okay? Makes sense for the most part? This is a pretty simple one. Let's try a slightly more difficult one. This one is written in slope-intercept form, both sides. Okay? It's written nice and neat for us to change it from slope-intercept form into substitution. You could have graphed it, plotted negative 14 on the graph, then go up 3, right 1, up 3, right 1. Plotted a 2 on the graph, down 5, right 1, down 5, right. You could have done that, and it may have crossed it. It may cross at a nice, neat point. But I also know that I could just take this chunk because it tells me y equals this. And I substitute it in for the y down here. So instead of it being a y here, it actually is 3x minus 14. And this side just comes down. Negative 5x plus 2. Now it's a two-step equation with variables on both sides. It's your choice. You can take the 5x, move it over here. You can take the 3x, move it over there. I don't care. I'm going to move the negative 5x because I don't want negative x values. It really doesn't matter. I mean, the negatives are one thing or another. 3x plus 5x is 8x. Add the 14. And I'm sure some of you are going, oh, I already see that this one's going to work out nice and neat. I'm hoping. Okay. 14 plus 2 is 16. And we know that 16 divided by 8 is 2. X equals 2. Not done. Here's again, your choice. You could take the 2, put it in for the x here, or put it in for the x here. It's your choice. What one do you feel is an easier problem to work with? Changing the x into a 2 here or changing the x into a 2 there? I don't care. Let's put it in the top one just because we're there. Put the 2 in for the x. It becomes 3 times 2 minus 14. 3 times 2 is 6. 6 minus 14 is negative 8. So y equals negative 8. So our ordered pair should be x value 2, y value negative 8. Don't just stop there. Don't just go, hey, cool, I'm right, I'm a genius. Substitute these numbers in for the other problem just to make sure. Change the x into a 2, change the y into a negative 8. Negative 5 times 2, negative 2, times 2, sorry. Negative 5 times 2 is negative 10. So negative 8 equals negative 10 plus 2. It does work. It works out just fine. Okay? Is that making sense? Now, do you want me to give you a problem where it doesn't work out nice and neat? Okay, I will. What I mean by that is, it's going to be a problem that looks nice, that looks easy, that looks like it works out beautiful, and then you start to see it worked out, and it's a holy crap storm. Okay, we have a problem. Y is equal to negative 3x plus 5, and then the other one is negative 6x plus y is equal to negative 1. Okay. Got problems written down over here. This problem right here doesn't look hideous, okay? Doesn't look bad at all. You've got what we want for this problem. You've got a variable that is isolated. You've got the y is isolated, and it equals this chunk right here. So let's substitute this chunk right here in for the y in the other problem. It tells us y is this. It'd be like saying y is equal to bananas. So if this is a y down in here, we know that's bananas down there. Y is equal to negative 3x plus 5. We know that the y down here is negative 3x plus 5. We know that it is. Bring down the negative 6x and bring down the equals negative 1. Oh, look at this. It's a two-step equation with variables that you have to combine. A negative 6x and a negative 3x make negative 9x. Bring down the plus 5 is equal to negative 1. Negative 5x, or negative 9x plus 5 is equal to negative 1. Subtract the 5. Negative 9x is equal to negative 6. Okay. Divide by negative 9, and you're already starting to see this is not going to work out so sweet and nice and simple. A negative divided by a negative is positive, and 6/9 reduces to 2/3. You're not going to find a 2/3 that often in graphing. It's a pain, okay? It's not an easy thing to find, but it's telling us that x is equal to 2/3. Now, sometimes you're going to be looking at a problem like that and go, oh gosh, I had to have made a mistake. The answer can't be a positive or negative 2/3. Okay, well, let's test. We take our x value that we found, x is equal to 2/3, and we have our choice. We can put it into this problem or put it into that problem. What one would you choose to substitute the 2/3 in for the x, the top or the bottom? I chose the top. Why? Because the y is already isolated, and if I change this into y is equal to negative 3 times the quantity of 2/3 plus 5, I've already got my problem ready to roll. I'm going to find out what y is. Cross cancel the negative 3 and the 3. I'm left with negative 1. Negative 1 times 2 is negative 2 plus 5. And y equals whatever negative 2 plus 5 is. Y is equal to 3. Okay, so we find the answer for that problem. Y is equal to 3. Now we have to take our answer and substitute the x in for the x here, the y in for the y here. So instead of an x, it's 2/3. And instead of a y, it's a 3. 3 goes into 6. How many times? 2 times. So this is actually a negative 2. Negative 2 times 2 is negative 4, plus our substituted 3. Does that equal negative 1? All day. all day and twice on Sunday. Okay, so solving this, our x value is negative 2/3. Oops, sorry, I'm going to put the cap on it. Our x value is negative 2/3. Our y value is 3. You're not going to find 2/3 on a graph. They're not broken into thirds for you to be able to find a nice, neat graph like that if you were to plot the points. Sometimes the substitution method is just the easiest method to do with these problems. Okay? That's the substitution method. I'm going to give you a small worksheet, small amount of problems that I want you to do. I'm going to post it probably, probably in about a half an hour. I may do a couple more on another video just to give you more examples because I really love the substitution method. I love when we get to systems of equations, but I love the substitution method. I will talk to you later. You have a good day. Happy Monday. Happy rain day. Bye.